In our new experiment today, we are going to find out if an egg would survive a drop from our school bleachers into a 2.45 meter pipe. We're going to hang a rope from the top of the bleachers to act as a guide for the person dropping the egg. So let's see if it works.
Based on our past experiment in which you drop an egg from the bleachers into a trash can of 0.78 meters tall, we think the egg is going to survive in our new experiment. We calculate that it didn't survive in the last experiment because the distance of the trash can wasn't enough to stop the velocity of the egg, and that we need a 2-meter pipe to do so. In the new experiment, we are going to use a 2.45 meter pipe, so the egg should survive based on it.
Actual experiment, we spent a few days of practicing and getting data for the probability of dropping the egg into the 2.45 meter pipe without missing it. The factors that could influence our data were the wind, so we decided to drop the ball when the wind was calm, the perspective of the person deciding whether it was a miss or a success, the ground, and the inclination of the pipe. We found out that the pipe was tilted to one side.
We tried in different parts of the bleachers to find out where was the best option to avoid the wind. That was a factor that was influencing our drop. The west side of the bleachers was the best place, so we started to get data there.
We dropped a tennis ball into the tube attached to the top of the bleachers with safety straps. We marked the ground with chalk and found the best place to put our pipe. We got different data on each of the different days.
Jamie, come over here.
Oh, yeah, that's me.
Tag these balls.
We dropped the tennis ball 10 times to find out where the best place to put the pipe was, and after we dropped the eggs. Out of 8 times, we missed 6. Some of them hit the side, but the other 2 made it inside the tube. Those 2 survived.
No. Not second place. Careful when you're bringing it up. Drop it. No. Now hold on. I think that was yolk from the other one.
No, I saw it from the next show.
Yeah, it's probably from the other one.
Nick, was it firm in your hand?
Yes.
He drops it on the ground.
Okay, let's say you made it.
Okay, let's see.
Good now. Let's say what?
This time set it on the ground.
Is this the last egg?
Yeah.
The last one was the fishing line.
Oh.
That sounds good.
Wait, I put full water bottle on.
I think it hit the side.
You have it with
I didn't hear a crack though.
Toss it
I hear like 6.
Drop it down.
on the grass.
Catch it like you catch the water bottle and set it down.
No.
On the way.
I said on the grass.
I tried to aim for it.
Stop doing stupid shit like that, please.
Why don't we just drop a water bottle? I have no
What was
idea.
that? Did you think it would make it? I thought you would catch it. It is good enough.
From the bleachers?
Yes.
Why? Why would somebody put themselves under the bleachers and get the water bottle? There's no rain right here.
Yeah.
Oh, I get it, to wash it off.
Survived!
It's survived.
When finding distances, we divide them into 3 parts: pipe, bleachers, and the difference between the 2. The pipe was 2.45 meters, bleachers were 11.38 meters, and the difference between the 2 was 8.93 meters. For the data, we measured the height of the bleachers, which was 11.38 meters. We then used a 2.45 meter pipe and 12 cans of shaving cream. We needed to find out whether or not our prediction would be right. In the last experiment, we found out that the egg didn't survive from the 0.78 meter trash can. The max height needed to be at least 2.04 meters. We need to find the prediction of the final velocity of the egg. It is a prediction because we didn't know when the egg would stop.
Predictions were right. The egg survived from our school bleachers, dropping it into the 2.45 meter pipe filled with shaving cream.